Well, hello everyone. In today's video, we're going to be talking about voltage drops and my solar array setup with the panels that I have. All right, here are the specs for my inverters. All right, so on the top portion of this page, it says input DC PV side. Okay, we see various voltages and working ranges and whatnot. So I want to say one thing. These are all Chinese volts and Chinese amps and Chinese watts. So whatever you see there, I want to say lower it down by 25% and probably your equipment will work for a very long time. Now, full load MPPT voltage range is what stuck in my mind and what I used when designing my solar array. Now, as we discussed, my solar array consists of 58 panels. Inverter 1 has 19, 10 on one circuit, 9 on the other circuit. Then the inverter number 2 has 10 and 10, and the inverter number 3 has 10 and 9, which equals to 58 panels. Again, pay attention to full load MPPT voltage range. That's where I decided to keep my voltage range on my panels. I do actually stay between 245 on a full load on 9 panels at this time of the year. It's probably going to be higher in like early to mid spring. And then upper voltage early in the morning when they first wake up says 365. All right, I'll keep up with the videos and try to show what we have in early to mid spring. So without further, as they say, ado, let's go see how we're going to measure this voltage drop. Since MPPTs always adjust voltage and amperage and pull different loads on the solar array, I will have to have a way to monitor voltages at the real time. Well, it's not going to be in the real time, but however, we're going to have one camera recording 1 voltmeter, and then at the same time when I start recording this, I will start recording on a different camera, and so we'll have a same time once we put it all together in a video editing software. So we can monitor voltages and make sure that we get correct readings. But first, let's calibrate the devices. So Klein tool shows 365 volts, 365.1 volt DC on the circuit, and then let's see what the fluke shows too. So in the real time, the fluke shows 364.8. So that's a difference of 300 millivolts. Let's test that again. Yes, at about 300 to 400 millivolt difference. So we will use that later on when we are calculating correct voltage drops over 530 feet. The camera is recording, so we got 334. I'm gonna go up there. I'm not gonna record this, disconnect. I'm not gonna stop recording with the handheld camera, but I have a GoPro recording this, so we have something to compare to time-wise. All right, let's go. Let's see what we have up there. Let's see how we're gonna do this. Turn it on. All right, camera is still rolling. So let's see if we can record anything. $340.05 at the minute 27, and this is number 1 array. That's the one that I have down there plugged in into the inverter 1. So 340.05. Two-minute mark. I'm at the full load right now. Sun is directly above us. Alright, so let's look at exact time of this previous video recording, what we had shown on the inverter. So timestamp starts at 1:29 according to my iPhone. So around 1:30 will be the correct timestamp. Let's see what amperage and what voltage and what accuracy we have from inverter. So let's find 1:30. So at 1:30 we have 334.8 volts at 5.6 amps. It was not on the highest load or 11-12 amps as I thought it would be, but it was at 5.6 amps. So we will take that number and use it to calculate the drop percentage wise. So let's talk about maximum voltage drop, what it would be for 530 feet worth of cable. All right, so the maximum amperage occurred on 11:19 a.m., which makes the sun still quite low over here. But at that time, I had 291.6 volts and 10.3 amps. I think this would be the best representation of what kind of a voltage drop are we going to have over this 530-foot run at the maximum load, because I know I can get probably around 12 amps, 13 amps in the middle of the summer, or at least middle spring. So at 291.6 volts with 10.3 amps, our voltage drops comes up to about 3.74 volts. That's exactly what I calculated when I was designing this array. I figured that I will have between 3 and 4.5% loss in between the solar array and the inverters. I'm happy, I can live with that, and the most of the time that drop will be between 2 and 3.5%. I want to say majority of the year. So with that being said, I think that all these online calculators, and especially one from Southwire, because that's a wire that I used, they are indeed very correct and can be trusted. All right, guys, I'll talk to you again in the next video. Hope we all learned something from this one.